Hello, my name is Pooja, and today we'll be discussing the blind cat blind rat problem of my Science 1 project. So, the assumptions that I have made for this condition is that the cat and rat take steps at the same time, that is simultaneously, and that the probability of the cat and rat at each uh, point is 1 by 4. So when we have a square and the grids, the at the boundaries the probability of the cat taking a step is still considered to be 1 by 4. That is, it can go up, down, left, or remain at the same point, as we can see here. uh, in the other places it can be anything, up, side, left. So and the same point, so I've considered to be 1 by 4. And at the edges the probability of cat and rat being at the same point is 1 by 2, so it can take either up, the left, or right, and uh, down, anything. So the next thing is, at time t equals to 0, the steps taken as 0. So let's say at time t, the total number of steps taken are t, and x denotes the steps taken in horizontal axis, and y denotes step taken in vertical axis. So next, so x plus y is equal to t, as from the before assumptions. So now probability of uh, the cat and the rat taking a step uh, in the horizontal axis and the vertical axis are independent of each other. So let's say n1 is the step taken in horizontal axis towards the right, and n2 is the step taken in vertical axis towards the above, so that is upwards. So now probability of cat or rat being at n1 comma n2 is probability of n1 into probability of n2, because they are independent of each other. So now probability of a cat or rat taking a step in the horizontal axis is similar to the 1D uh, probability of a random uh, walker taking a left to right, or a step to right or left. So that is total steps in the horizontal axis x computation n1, that is to right, and 1 by 4 power n1 and 1 by 4 power x minus n1, since probability of taking a step is 1 by 4. So now the total probability will be xcn1 and 1 by 4 power x. Similarly, for a step taking for rat or cat taking a step towards up, that will be t minus x, that is steps taken in the vertical axis, cn2 1 by 4 power t minus x. So now probability of being at n1 comma n2 is summation of x, because x is variable, that is number of steps taken in horizontal axis can vary from minimum n1 to maximum uh, t minus y minimum, that is n2. So that will be summation x p of n1 into p of n2. So as stated, x minimum number of steps that has to be taken in x direction is n1, and then y minimum will be n2 for a rat to be at n1 comma n2. So x max will be t minus n2 y minimum. So summation over that, you will see probability of n1 comma n2 is summation x equals n1 to t minus n2, xc n1 and 1 by 4 power x, t minus xc n2 1 by 4 power t minus x. So uh, yeah, probability of rat or a cat being at n1 comma n2 is given by this equation. So we have two cases, one where the cat and rat start from the diagonally opposite corners of the square. So the total number of possible steps will be n, because L square is the area of the square, the larger square, and R square is the area of the smaller grids. The edges of each grid is the point of possible step for each cat and rat. So probability of them meeting will be probability of rat being at n1 comma n2 and probability of cat being at n1 comma n2. So at the same time both have to be in the same place. So that will be probability of rat coming from 0 comma 0 to n1 comma n2, and probability of cat coming from n comma n to n1 comma n2. So the boundary to include the boundary conditions, we have kept this summation where n1 can range from 0 to n, that's the maximum uh, uh, number of steps that can be taken inside the square grid. That's the maximum boundary condition. And then n2 also ranges from 0 to n. Since it's a square both in the horizontal and the vertical axis, it will be n. So into probability of rat will be summation x equals n1 t minus n2 to xc n t minus xc n2 1 by 4 power t into x equals n minus n1 for cat, because it's not starting from the origin, to t minus n plus n2 xc n1 t minus xc n2 1 by 4 power t. So this is the probability of them meeting. So the probability of survival will be 1 minus probability of meeting. In case 2, similarly, both since both are starting from the same place, the summation, the probability of meeting will be summation n1 equals 0 to n2 equals 0 to n1 to n to n, and summation x equals n1 to t minus n2 xc n1 t minus xc n2 1 by 4 power t whole square. So probability of survival will be 1 minus p of meeting in both the cases, and that is given by these two equations. So the second part of the project includes the probability of survival of cat in a spherical world. So in this case, the cat and the rat are diagonally opposite to each other on a sphere. So the cat and rat can take any step on any of the points on the surface. So according to spherical coordinate system, we will calculate the probability. So here theta is angle made with z-axis. Cat and rat could be anywhere on the ring once we take a particular theta. So to calculate the probability of the cat and rat being anywhere on the ring, we have to consider the location points for anything to be on the ring. So that will be done by alpha. Alpha is angle made with x y plane. So r is radius of ring. So let the cat and rat take equal steps on the surface of the sphere of length d. So p alpha will be probability of alpha will be arc length by total circumference, that will be r dash d alpha by 2 pi r dash. R dash is the radius of the ring, and p theta will be area of ring by total surface area, that is r d theta 2 pi r sine theta. This will be 2 pi r sine theta by pi r square. So probability of rat and cat being at the coordinates theta comma alpha will be p of theta into p of alpha, because they're independent of each other, and probability at a given time is therefore equal to d theta d alpha r into r by 2 pi r sine theta divided by 2 pi r 4 pi r square. That will give d theta d alpha sine theta by 4 pi. A slight correction. Yeah. So after displacement d, let alpha theta be at the new coordinates alpha dash and theta dash. So d can the new step that they have taken can be in any direction from the previous location. So let's assume that this step was taken to somewhere in the first quadrant. So if we consider a sphere, it can be in any one of the 4 quadrants. So let's consider it's in the first quadrant. So any point in a sphere can be located by the longitude and the latitude of the taking the longitude and latitude of the sphere. So let A be the longitude whose angle with xy plane is alpha, and B be the angle made by latitude with z-axis and theta. So the displacement d theta will be arc length by radius, that is d cos b by r, and the new theta dash will be theta plus or minus d cos b by r, whether it was taken with considering the initial conditions, whether it was taken to right or left, and d alpha is d sine b by r sine theta. So new alpha will be alpha plus or minus d sine b by r sine theta. So this plus or minus can be upwards or downwards depending on the initial conditions taken, assuming that the steps are like really small, so that we can make the rat and the cat cover the entire sphere. The probability density function will be given by f of theta comma alpha, that will be probability of theta comma alpha, the probability of being a theta comma alpha into d theta and d alpha. So my f theta comma alpha, that is probability density function, will be sine theta d theta d alpha by 4 pi. Sine theta by 4 pi into d cos b by r and d sine b by r sine theta. So that will be d square cos b by sine b by 4 pi r square. So the probability of meeting can be calculated by integrating the probability density function to get the total probability. That will be integrating with it with respect to theta, alpha, and the whole square, because the probability will be the same for cat and rat with respect to d theta and d alpha. So that will give us d alpha d theta, the whole square of this probability. That will be d power 4 sine square b cos square b into 2 pi divided by 8 r power 4 into pi square into 2. So probability of meeting will be d power 4, where d is the a step, sine square b cos square b by 8 r power 4. So probability of survival will be 1 minus probability of meeting, that is given by this equation. So now answering the questions. First one will be how is the probability of survival dependent on time. So from the equations that we derive for probability of survival, it's clear that the probability of survival is inversely proportional to time. So as t increases, the probability of survival decreases, since there is at some point the cat will eat the rat, since they are bound to meet at some point. So as t increases and as t becomes very large, the probability of survival will be 0, because the cat would have eaten rat at some time. So the second question is survival, probability of survival with the length of the square and the radius of the sphere. So from the equations we notice that probability of the square is directly proportional to the length of the square. So that is a probability of survival is directly proportional to 1 minus 1 by L square. So when L is very large, the probability of survival is almost 1 for a long time. So next, considering the radius of the sphere, probability of survival is proportional to 1 minus 1 by r power 4. So that is the radius of the sphere. So as r increases, the survival probability also increases. So the third question was what if the steps are like infinitesimally small and the number of steps is very large. So this condition is comparable to the collision of two atoms in a gas. So the steps are like very small and the number of steps are really large. So probability of survival is can be considered as each point on the surface of the grid divided by the total surface area that's available. So 1 point, so that will be 1 minus probability of rat into probability of cat, that will be 1 minus 1 by L square into 1 by L square, that will be 1 minus 1 by L power 4 for the first case, and for the second case it will be 1 minus point in the square of the sphere, a surface of the sphere divided by a total surface area whole square, that is for the probability of cat and probability of rat. So that will be 1 minus 1 by 4 power 1 by 4 pi r square whole square. So that will be 1 minus 1 by 16 pi square r square. So that is how the problem was solved analytically. Thank you.